Hi there, welcome back. We're past another milestone in this restoration, and that is the AM tuner parts. So I'll just go through what I did and what I found. There are a couple of interesting points that I picked up while doing this checking. There wasn't much in terms of substitution. A couple of capacitors. One of them very important because it's the AGC one, but I'll show you that in the schematic. But other than that, the AM section, although it did sound a little bit deaf when we tried it initially, quite frankly, I was so happy there was sound, I didn't bother about the quality of reception. One thing at a time, right? The AM section didn't have that much wrong with it. So my guess is that the alignment was probably out, and that's what we're going to do in this video as well. See what the alignment's like, and then we'll be ready for the final stage, which is the FM section. Yeah. All right, let me go to the schematic and show you what was done and what I found. This is what we have so far. As you can see, quite a bit of it has been painted in. I did do this stage, the AM checking in blue, so that we can get an idea of how that separates from the green, which in this case was the power supply, and in the other schematic was the amp as well, the power amp. So what I basically did is started from the beginning, which is the antenna. Signal comes in through a 220 picofarad capacitor, goes into here, which is a switch that selects the band. Now that switch is obviously multiple poles, but in this particular case it will determine whether you are selecting shortwave or if you're selecting medium wave and long wave. The shortwave input tuning is here. Now the way this works is this is really just a pre-tuning, and then the actual tuning is done when it mixes with the oscillator signal. So there isn't really any active tuning on here except presets to adjust the actual RF alignment. But this is the short wave, then you've got the medium wave and the long wave. Here you've got the ferrite antenna. You've got a couple of presets, adjustable capacitors and coils. The alignment is done on the other side. This is to strengthen the signal for particular frequencies. So this basically tunes the front end to the band that you are selecting. So nothing wrong was found here. Some of these are pretty difficult to ohm out because you've got coils that are very low resistance. So in some cases, the way to determine whether you have a coil or a short is literally a couple of ohms. For example, from there to ground, you have this coil. There's that coil over there. That thing could probably be, 3, 4, 5 ohms. So if you're not careful, you think you've got a short, or you think you've got a coil and you've actually got a short. So you've got to be pretty careful, think of what you're doing, see where these connections go. In some cases, you can't measure anything because it's shorted on another switch. So you basically follow the circuit, try and determine that all these connections are there. I didn't measure things like these trimmer capacitors. These are assumed to be correct. These caps here, for example, I wouldn't measure that. I would assume them to be correct because these are ceramics in some cases and polystyrene ones on others. They always, generally, always keep their value. But then you take the signal and it goes into, it follows up here. You've got this tuned circuit over here, and then you've got there's a tuning capacitor over here. That's the first gang of the tuning capacitor that we see at the top here. And that goes into part of the selection switch into the ECH81. This switch selects between the AM bands and the FM. We're interested at the moment only in the AM bands. So AM goes in there. There's a resistor here, this 1 meg. This is actually coming down to there, which is an AGC signal, automatic gain control, that's produced in the detector section. So this is the mixer oscillator tube, which will produce, in the case of the AM bands, a 460 kilohertz intermediate frequency which will come out of pin 6. Okay, so whatever frequency you got coming in here, you need a corresponding frequency with a difference of 460 kilohertz coming out of your tune circuit, of your oscillator circuit, to produce that difference. It actually comes out in various mixes of the two frequencies, but the one we're interested in, is the difference, which should be a modulated 460 kilohertz carrier. That carrier is the IF frequency, which then gets tuned with the IF coils and transformers to pass that through, and at the end you take the modulated signal, which is your audio. Okay, so we've got that coming in. That all worked out quite well. Then we have this section here, the second part, the triode part of the ECH81, and that is the oscillator circuit. And if we follow that down, we have another 3 sections of tuning over here with various selections going on. And this is really the part that selects which band you're going to work with, and also you tune it with a second gang of that capacitor. Again, nothing dramatic found here. It all seemed to be okay. Resistors measured well, continuity measured okay. It was fairly easy to determine that these coils were all working. Remember, it's actually a bit of a cheat knowing that this thing is receiving, but we check it nevertheless. And then we come to something here which is quite interesting, which is this part here that goes into the FM section. You see this dashed line here is that FM can. And I couldn't figure out what the hell part of the oscillator circuit of the AM bands, because this oscillator only works for the AM bands, what the hell was that doing in the FM can? And then I remembered something. We have something called a KW looper, which is fine tuning for shortwave. And what this is, this thing here, if you look at this, you've got one of these, 2, 3. Now these are inside the FM can. These are plungers, so these are cores, variable inductors. And as you turn the dial of the FM, these things go further in or out of the cores, therefore changing the inductance. And this is what is used for tuning the FM, both the oscillator section and the front end section. So this thing was for FM, but there's one sitting over here, which is also, it's connected to ground on the one end, and it's connected through this whole circuit to the oscillator of the AM. And then I realized what this is when you use the FM tuning dial as your shortwave fine tuning, that's the core, that's the inductor, the variable inductor that's being used to adjust your oscillator frequency slightly and therefore give you a fine tuning capability. So that was checked to the entrance there as well. Moving backwards, we would then get the signal coming out here, through there, through these cores, through these transformer windings on the IF transformer. This is IF transformer 1. This was already checked for continuity when we did the power supply checks, and there's 2 of them. Now, the top ones are FM, the bottom ones are AM. The beauty of this all-in-one system is that when this thing is passing FM frequencies, in the case of FM, the IF frequency is 10.7 megahertz, this thing has no effect. It's not tuned for that frequency. It's completely out of the range. When this thing is passing 460 kilohertz, which is the AM IF frequency, the top cores have no effect, or practically no effect. So you can use this in series and you get the same result. So this was checked as well. Again, without opening the can, you measure from some of the input pins and check what values you get. And most of these you can check from the outside. So then we have the signal coming out, and it goes to the first EF89, which is the IF amplifier. That simply amplifies that signal. It'll amplify 10.7 megahertz with FM modulation, and it'll amplify 460 kilohertz with AM modulation. That signal then goes through to that IF can. The same thing happens here. You tune it, and we'll be tuning those cores to get the best cutouts, or rather the best pass-through at those respective frequencies, and then this thing comes over to the second EF89. Now from here, we've got the red line down there. I continue on the other schematic, on the other page, and here it is. It's on the edge. Comes in here, gets amplified again. Then it goes into the last IF transformer with the which has that EABC 80 tube in there. That's the last can. And again, it's got an AM circuit, which is this part over here, and it's got an FM circuit, which is this part over here. So just looking at the AM side, everything seems to be working pretty well, connected pretty well. The signal, the AM signal, comes out of here. This will now be an audio signal, and it goes to the audio selector switch. This switch selects between audio from the radio, so AM or FM, and we've seen that before because that then goes off and joins where the input from the pickup is going to meet it. So everything's been checked to the end here. What we also have here is from the audio. The audio has a DC component on it, which is created by that diode over there, the detector diode. And what this does is it gives us a negative voltage proportional to the strength of the signal that comes through there, to the strength of the carrier that comes through there. And that voltage coming down here through that 1.5 meg resistor is smoothed or is used to charge this 47 nanofarad capacitor, which is the AGC cap. And this is important. This one was completely buggered. I measured like 1 nanofarad. So this one was definitely not working. Now the result of that is that the gain of the various stages would be less related to the strength of the signal, which is really what the AGC does. If you have a very strong signal, there's a fairly high negative voltage here. So what it does is it cuts off the bias from the tubes and lowers their gain, so that a low strength signal sounds more or less the same volume on the speakers as a very strong signal. That's the idea anyway. But this thing was changed, and what we have now is we literally have the signal coming to that selector switch and going to the amplifier. So we have the whole circuit, as far as the AM is concerned, done. And what we need to do now is check that it works, and then we need to tune the AM. And the tuning is very simple. We need to tune the IF transformers for the best pass-through at 460 kilohertz, which is the IF frequency. So what we need to do, we have instructions here as well, but it's very simple. You put in a signal there, and what you put in is 460 kilohertz carrier, modulated, 30% modulated with an audio signal of 600 hertz or 700 hertz or 1 kilohertz, whatever you prefer. And you put that, you couple it to there via a DC blocking capacitor, and so you're basically feeding in the carrier signal equivalent to the IF frequency. So when that goes straight through there and comes through here, you then tune these two. These are the AM coils that you need to tune, and I'll show you that on the radio itself. It then goes through there, and it gets amplified, comes through there, and then we need to tune these two. And the way we tune it is we put in the signal and we measure the level of the output audio. That's really what we're looking for. Okay. We could also measure the value of the AGC voltage, but let's do the audio here now. So when it goes through this one, it goes into that, which is the second EF89, and then we have this part of the circuit, the second EF89. It goes through there. We tune those two, which are the AM transformers, and at that point we're getting a optimized audio level signal coming out here, and we then measure that level at the speaker outputs. Okay. Now the thing to do here is to put in a very small signal, as small as possible, so that the AGC, the automatic gain control, remember that DC voltage that comes out of here, here, and goes to that capacitor? That should be as small as possible. So we don't want a strong signal because we don't want the automatic gain control to affect our adjustments as we adjust those two. Now, because this thing was fairly insensitive when I tried it, and because I didn't find anything dramatically wrong with it, except for that AGC capacitor and one or two others, my guess is somebody tweaked these transformers. My guess is that they're pretty out of tune. Now, what I need to do is I'll show you on the rest of this service sheet exactly where the transformers are. This is the drawing that tells us, this is looking at it from the back. We've got that first IF transformer over here, the second IF transformer over here, and the third one is inside that cam that has that last, or second to, well, the EABC80 tube. And what they tell us is that they give us instructions here, basically what I've told you, and they tell us that we have the AM cores are the external ones. This is looking at it from the top backwards, so the ones further to the edge. There's one at the top and one underneath. One at the top, one underneath. So this is the IF transformer 1, IF transformer 2, and in the case of the last one, IF transformer 3, there's one at the top here and one underneath. It's the two that are furthest away from the tube itself. We have to be careful we don't mess with the wrong ones, otherwise you detuning the FM intermediate frequency. So let's set this up. I'm going to set it up with the signal generator and I'll show you the steps and then we'll see what we get. So as usual, we have this setup. Signal generator set to 460 kilohertz sine wave. It is set to 1.4 millivolts RMS, which is the lowest that this particular signal generator will go. This is still too high for using, so I'll show you what we do next. This thing is modulated, 30% modulated with a 600 hertz signal. Modulation is on, and I can activate it just by activating the channel there. What I have here is a little selectable attenuator. I can attenuate 6 dB, I can attenuate 12 dB, or 18 dB, or any combination of those, up to 36 dB. So I can make the signal as small as I like. And the signal amplitude I will determine when I look at it on the scope and see how small it can be and still be discernible as a 600 hertz sine wave. The signal from this point then goes to the radio, and I have it connected to ground here on the chassis, and I have it connected to pin 2 of the ECH81, which is the mixer oscillator. I'm going to do this in one go. You could actually start by connecting it to pin 2 of the second IF amplifier, the second EF89. I've decided I usually do this, go straight from the beginning, go through. The other things they tell you to do is to select the bandwidth of the bandbreedte, the width of the band pass, so you make it as sharp as possible. It's on medium wave. The tuning dial is about in the middle. You don't connect an antenna. You don't want an actual input signal on here. You want it to go just to receive the one coming out of the signal generator. This has got to go to pin 2 through a 10 nanofarad capacitor. But because my attenuator is AC coupled with a 10 nanofarad capacitor, I'm connecting it direct. You do not DC couple this thing to the signal generator. Then we connect the speakers up, and we have the scope connected. Now the speakers, I've connected both sets of speakers to the dummy load, actually to speaker and dummy load. We only really need to follow on the scope the one, because this is a mono signal. So we'll just put that on now, make sure everything's okay, and switch on. With the dimmer all the time, it's come on. Seems to be okay. I've activated the signal, put the volume fairly high, and see what we get. We should be hearing something soon as the heaters, as the tubes warm up. There we go. You can hear that and you can see it. Now, there's a very, very strong signal coming in here. Let me just, sometimes when there's no modulation, right. When it starts off like that, sometimes the modulation doesn't work properly. We've now got a 600 Hertz sine wave modulated on our carrier of 460 kilohertz. And I'm going to increase the attenuation. So I'm going to drop the signal amplitude. It's very high. There's 6 dB. That's 18 dB. That's too much. I think we can probably get away with that. Maybe not. It's a very low signal, actually. Anyway, let's see what happens when we start tweaking those cores. Now, I'm going to start with the cores. You do one on top, one at the bottom. I'm going to start with a 2 on the last IF transformer. And what I use for this is a little wooden screwdriver. Might sound strange, but it's one of those kebab stick things, which I sharpen the end there. And what this means is that it is weaker than the ferrite cores inside the transformers, so it won't break the transformers, because you can break them. So let me start with the last IF core, and it's on the top side. See if we get any joy. A little bit. It's on 75. I'm getting quite a bit of change here. I'm reading the RMS voltage on there. It's just a relative figure anyway, but I am getting quite a bit of increase here. It went from 50 to 80 something. I think that's about it on there. Let me go to the underside. I'm now on the underside. That's gone down, so let's try the other way. Well, the core's loosened a little bit, so my wooden stick might be able to change it now. That's going down. That's going down, so that is the peak over there. Now, I can see the change in the amplitude, but I'm actually going more by the reading over there. So I've got a peak over there. Now I'm going to move one core back, one transformer back, and do that core and see what we get. No, that seemed to be more or less at a peak. That seems to be a peak over there. Okay, now we'll do the top one, see what we get. Whoa, whoa, see that? That's a peak over there. That's actually too high for this. See, someone did tweak this. That's fantastic. That means that we found the main problem. That's nice. I'm actually going to put this on dummy so we don't have to listen to it. That's nice. That's a nice increase we got there. Let me go to the first IF transformer. See if we can improve it even more. Yep, there's a little bit of improvement there. Whoa, whoa. Something strange going on here. Okay, so what we've got there is a pretty high signal, and it's probably affecting the AGC. Let me take off modulation. A lot of noise. I wonder if I haven't got this thing inadvertently. It's quite a bit of noise. Let me see what I can improve on here. No, we've definitely got a peak over there, but that's a very nasty looking waveform, which shouldn't be like that. Let me put speaker. A lot of hiss. Why do we have so much hiss? Let's take off this. Okay, I can take the hiss down. The tone was very, very high. Makes a difference. Okay. Okay, that's a good signal. It's about the peak. I've also just crumbled my wooden screwdriver. Got to keep sharpening it. But better that than the core breaking, right? Lower, higher, lower. That's about the peak over there. Let's go to the top one. Lower. That was more or less okay. That's it. I think we've peaked it. It's pretty good. That was quite an improvement, and I'm sure that the reception will be a hell of a lot better. So I'm just going to tweak these again, just go through them again, and at that point we'll be ready to do a reception test. Okay, we're ready for a reception test. I've connected the original speakers, the radio speakers, to the back. That gives us the best sound. The speakers are actually turned away from the microphone, but I think you'll probably hear well enough. Switched it on. It's on medium wave. Let's see what we get.
Quer avisar sobre eventual fraude nos contratos com os treinadores Carlos Pinto e Luís Pires de Santa Clara. Estreia-se no campeonato dos Barreiros diante do...
Now that is the 1 AM channel we get in Madeira, and it's bloody clear. Now what I have got is, if you see this here, the ferrite antenna is set to external. If I did that, it gets lower because now I'm receiving just on the ferrite. I'm using an external antenna with a it's a mini whip antenna which receives very well, and so that's what we get. Obviously we get other channels, other stations, mostly from the Canary Islands. That's from Morocco. That is Canary Islands. It's pretty good reception from the Canary Islands to here.
Estados Unidos, el fuego está también sembrando el pánico en California, que
Okay. Long wave we should actually try at night, and I'll probably do that later, but let's see what we get now. Very faintly, this is a French channel here. One of the beacons. Okay, let's try shortwave. That's that one. Now with shortwave, if I set it in the general vicinity and I tune with the FM tuner, that's my fine tuning. Watch. Let's get something first. See that?
Et aussi, quand c'est la 4e mission d'élimination organisée par le Mossad en territoire étranger contre des experts en armes. Michel Paul, Rémy.
Mais quelle est cette instance qui peut sélectionner les candidats, sinon le peuple?
Off the show? Even more colorful.
I know, give him a few weeks and he'll be in my time.
Yeah, I think he's
Also,
quickly settling in and we're assimilating him. Yes. The Grand Channel is just a fun team.
I think that's American station, US.
Here, and but it's our nice to have you and your listeners with us. We have some fast.
See, when you got two stations very close together, you can put it on one and watch for the fine tuning. There's the other one. It's pretty busy at this time of day, that part of the band. This side's more quiet. But you get the idea, this thing is actually receiving very well at that part of the band that's very active this time of day.
One of the wings of the Union for Democracy and Social Progress, UDPS, and one of former Prime Minister Abdul Hamidito, who has been...
What you can do is change the bandwidth of the received signal. Watch.
But his candidacy is coming as an independent since Mosito is suspended without a delay.
What it does is allows you to tune better when you've got lots of stations next to each other.
El señor Binali Yıldırım, el último primer ministro de la República de Turquía, antes de pasar.
Well, nice, very nice. Now this reception is on par, and I'm giving you a comparison based on what I receive here. Obviously, it makes no sense to compare it to anywhere else. What I receive here, this is on par with any of the other Telefunkens I've done. It's on par with the SABA that I have, which is probably one of the best. It's a SABA FREIBURG 8, probably one of the best FM shortwave receivers from that era, late 50s, early 60s. So this thing is very, very sensitive and selective. So I'm very, very happy with the AM part of it. And of course, what I and everybody's been waiting for is this bugger. And nothing. Absolutely nothing. Now, what I do know about this, one of the possibilities is that this thing here, this wheel, what it does, it doesn't actually turn a tuning capacitor. It actually turns a pulley system of ferrite plugs, so variable inductors. And sometimes the string is broken, which would be a fantastic repair. I mean, this would be the best thing possible. But I happen to know the string's not broken. Not because I've opened that, but because this bug is working. Watch. So if one of those plugs is working, the one that's used for the fine tuning on shortwave, then the others are working as well, so the string is not broken. So that possibility is out. But anyway, that's for the next episode. I've got a lot of work to do here to try and figure out what's wrong with this. I'm actually looking forward to it because the rest is coming out very nicely. And when I get that done, and says he with great confidence, I'll come back and report to you. I hope you've enjoyed this episode and hope you've learned something. This alignment was done pretty fast. I've actually tweaked it off camera because that noise we were getting on that wave there was that the ground wire wasn't properly connected, and I discovered that when the camera was off. But it was fairly close to the alignment that we wanted. It's obviously very far from where it was. So we did increase and improve the sensitivity on this thing dramatically, which is what I expect from these radios. So you get some very, very good reception, not only on FM, but also on the AM bands, if that's what you're into. Now, fair enough, not many people are, but that's not the point. The point is restoring the radio. The point is not what people are going to listen to or not. So yeah, so speaking about that, they listen to FM. That's my next challenge. And I'll see you back soon. Thanks for watching. And if you like this, subscribe. Bye for now.